This video is to help students and parents with the canoe problem, problem 2.3 from our Thinking with Mathematical Models book. Like the previous problem, the car wash problem, the canoe problem, as I call it, problem 2.3, deals with linear relationships in real life situations that students can relate to. In this problem, we're looking at a boathouse, Sandy's boathouse, that rents canoes, and the equation they use is C equals 0.15t plus 250, and that's the cost for renting a canoe is 15 cents per minute plus a $2.50 one-time startup cost. Those are the kind of things that we talk about in class when we address the first bullet in the getting ready part right here about what do the numbers and the variables mean in our situation. So next we meet Rashida and Serena, who are applying for jobs at Sandy's boathouse. And I like to have the students put themselves in the situation, which is the last part of the getting ready, pretending that they're applying for a job. So a manager is going to ask them some math-related questions to see if they are math competent. And we're also looking at how well they explain themselves and can articulate their ideas. So the first question is, what is the charge for renting a canoe for 30 minutes? And students are having to decide what part of the question they know the answer to and what part they're looking for. In this case, they know the time is 30 minutes and they're looking for the cost or the charge for renting a canoe. So they would put that back in the equation where C equals 0.15, and instead of T, they'll put 30 minutes in for T, and then they will solve this equation for the cost. So 15 cents times 30 minutes would be a total of $4.50. Add to that the $2.50 startup cost, and you get a total of $7. So the second question takes on a slightly different twist. This time the customer is charged $8.50, but we don't know how long they use the canoe. So now we use the equation in a different way. This time we know the cost, so we'll put the cost in place of C. It's $8.50, and that equals 0.15 times T plus $2.50, and we have to work backwards now solving this equation to solve for the time. So to do that, I would subtract $2.50 from both sides of my equation. That would leave me 0.15 times T, or 1.15 T on the right side, and on the left side would be $6. So essentially that eliminated the starting cost in our equation. Now I divide both sides by 0.15 to undo the timesing by 0.15. And T equals 40 minutes. So a customer that's charged $8.50 could rent a canoe for 40 minutes. Now the final question in the getting ready section is similar to the last one. A customer has $10 to spend and the manager wants to know if we can tell them how long we can use a canoe for. So like the last example, we're going to put $10 in the cost portion of the equation and we're going to solve for T. So rewriting this with the cost replaced, we're going to subtract $2.50 from each side of the equation again, and we'll get 0.15 T on the right and we'll get $7.50 on the left. So we're almost done. We need to divide both sides by 0.15 once again, and this time T equals 50. So $10 will get you 50 minutes renting the canoe. Our learning target in this lesson is to find the slope and y-intercept from tables, graphs, and equations. And in the first getting ready portion, we used an equation. So part A, question A in this problem 2.3, uses a graph to find the same information. So from a graph, we can answer those same three questions the manager posed in our problem. The first question was, if a person rented for 30 minutes, how much did it cost? And we can use our graph to find that information. So since we know the time, we're going to go along the x-axis here until we find 30 minutes. And then we're going to go straight up until we connect with our line. And that our axis would intersect at that line sort of there. And then we're going to go straight across from there to our other axis, the y-axis. And we see that 30 minutes would correspond with $7 on the other axis. So 30 minutes costs $7. Now we can also work it the other way. If we knew the cost, we can look on the y-axis or the charge axis, and we can go up to $8.50. That was our first question. So it's between 8 and 9, and here's 9, so 8.5 would be right about here. We could go across until we hit our pink line, the graph of the equation, and then we can drop down to the cost axis, the rental time axis, which is the x-axis, and find that that was 40 minutes. Likewise, we can look at the time or the cost for $10 and go across and find that that has a time of 50 minutes, which verifies the answers we got earlier. Question B asks us to answer the same 3 questions posed by the manager, but by using a table instead of a graph. So if we were going to do that, probably we would want to make a table first so we can see how to answer the questions. So then make a kind of a T table, one being the X and one being the Y variable. We're going to call them T and C because the independent variable is time and the dependent variable is cost. And we'll probably want to start our time at 0, and it might be appropriate to go by tens in minutes. Some people go by fives, and that's okay. You probably wouldn't want to go by single minutes because that would make a very large table, but you could. But I'm just going to go by 10-minute intervals. And then what we'll do is we'll fill in the cost in the other column. So 0 minutes would cost $2.50. We already did our 30 minutes was $7, and our 40 minutes was $8.50, and our 50 minutes was $10. And what you'll notice about this pattern is it's pretty easy to fill in the table. You could use an equation and input our time into it and find the cost, but we also notice that because it's going up by 15 cents every 1 minute, that it's going to go up by $1.50 every 10 minutes. So if I just keep adding $1.50 each time, I can figure out how much these costs are. So 10 minutes would be $4, and 20 minutes would be $5.50, and down here 60 minutes would be $11.50. And now students can use their table to answer the same questions. For example, if we looked at 30 minutes, it would cost $7. And what we do is we find the quantity we know in its column, and we look at the other column that corresponds with it for the other number. So 30 minutes costs $7, whereas if we had $8.50 to spend, it would correspond to 40 minutes, and $10 to spend would correspond to 50 minutes, and so on. Now for the sake of this video, I'm just going to highlight part of the problem, so I'm going to skip to question part E from problem 2.3. This part introduces a new company called Riverfront Paddle Boats, and they have a different equation for renting paddle boats, which is C equals 4 plus 0.10t. Now you notice right away about that the starting value has been put at the front of the equation, which is fine. And so this one says that the cost is equal to $4 plus 10 cents a minute to rent a paddle boat. So now we're asked to answer 3 questions. One is a customer at Riverfront is charged $9. How long did the customer use a paddle boat? So we'll use the equation and put in the $9, and that would be our cost. So we'll put 9 here, and that equals 4 plus 0.10 times time. And this time we know the cost, but we're looking for time, so we'll solve for t by subtracting 4 from each side of our equation. This should look pretty similar to the other questions we did earlier. We divide by 0.1 on both sides, or 10 cents, and we find that that equals 50. So for $9, you can rent a paddle boat for 50 minutes. Now question 2 says we want to spend $12 at the most. How long could you use a paddle boat? So this time we know the cost again, and we want to look for the time. So just like the last example, we're going to put in $12 for the cost and solve for t. So subtracting 4 from both sides. That should be a minus 4 there. So I get 0.10 t equals 8. Divide both sides by 0.10. And t will equal 80 minutes. And our final question on part E, number 3, is what is the charge to rent a paddle boat for 20 minutes? This time we know the time, so we don't know the cost. So we'd put C for cost equals 4 plus 0.10 and times that t, which is this case is 20 minutes of time. And so then we get 20 times 10, or $2, plus the $4 equals a total cost of $6. I hope this video was helpful for you understanding the canoe problem. If you have further questions, please email me at this email address.